In this tutorial, we're going to cover creating a timeline for triggering time-of-day events. A couple of lessons back, we programmed the System Off button on our touch panel to shut down the entire system. In addition to that button, we also want to schedule a time-of-day event to shut it down in case someone forgets to press the button on the touch panel. This will be a repeating timeline with a single time element in the time array, which occurs once every second. Before we do this, we need to make sure we're working in the correct source code file. Shut down your P1 exercise file if you haven't already, and open up the lab master source code file. Let's start by reviewing what the time keyword does, and what it represents before jumping into the code. While you may already know that the time keyword returns an 8-character string representing the current time down to the second in 24-hour format, it's worth mentioning what actually happens. Each time the time keyword is called, the current time string is placed into a global variable called time. As we learned earlier, changing global variables in the Define Program section is not a preferred practice, as this may greatly affect the master's CPU usage. Before timelines, the time value was checked in the Define Program section to see if it was equal to a specific time. If it was, some process was started, or some sequence of calls were made. For example, you may want to turn off a video codec at 11 p.m. and turn it back on at 7 a.m. to save the cost of energy when you know the unit will not be used. Because of this setting of the global variable time, each time through the Define Program section, it's no longer desirable to make this call in Define Program, as it eats up CPU cycles unnecessarily. For this reason, using a timeline for time-checking events is preferred. Because timelines have a specific repeat time, they don't have the same issues as using Define Program does, especially when using an NX processor. Let's take a look at how we can implement a time-checking routine to kick off other operations by checking the master clock's time once per second, and if the current time is 10 p.m., we'll execute the system shutdown. We'll begin our example by defining a timeline ID. This timeline ID must be a long constant. So, let's scroll down to the Define Constant section. We'll call it TL underscore every underscore second. Let's use ID number 6. Note that the timeline ID must be unique within the mainline code. You might be wondering, why did we choose 6? Well, it was completely random. Choose whatever number you wish. Next, we'll scroll down to the Define Variable section and define an array of longs to represent the time when a new minute occurs. We'll call this L every second. Because we'll be repeating this value, we only need one time in the array. The timing's in milliseconds, so for a 1-second interval, we'll use a value of 1000 milliseconds. Next, we need to create this timeline. Creating the timeline will also start it running. Because we want to start this timeline as soon as possible, we're going to create it in the Define Start section. To create the timeline, we use the function timelineCreate. There are 5 parameters inside a set of parentheses. The first 3 parameters are the timeline ID, which was TL every second, the array of times, which was L every second, and the number of times provided in the array. Sure, we could put a 1 here, but the better method would be to use the simple keyword length array. Then, inside a set of parentheses, we put our array, L every second. We have one time in our array, 1000. Therefore, the length of that array is 1. If we were to add 10 more times in that array, the new length would be 11. The fourth parameter specifies whether we want the times in the array to be considered absolute times from the start of the timeline, or relative times from one time value to the next. For our example, we want the time to be absolute. So the keyword is timeline_absolute. The final parameter specifies whether we want the timeline to run once or to continually repeat. For a once per second event trigger, we want the timeline to repeat indefinitely. This is specified by the keyword timeline_repeat. Our timeline is now created, and every time the master gets rebooted and runs through the defined start section, this timeline will be created. The final step is to actually write the code to do something at a specific time. It's considered best practice to always place your timeline events as the last type under the Define Events section. Scroll down to the bottom of the Define Events section and create a timeline event using the ID of our every second timeline. Within the curly braces, we can put our checks for given times based upon hours, minutes, and seconds. For this line of code, we want to compare the value held in the global variable called time inside an if statement. So we simply type out if time equals 22 hours, 0 minutes, and 0 seconds. Now, every night at 10 p.m., what is it we wish to do? Well, we want to shut down the system. If we scroll up just a bit, we already built a button event using dvtp and the system off button. Instead of writing all this code again in our timeline event, it sure would be nice to be able to simply trigger that button event. Of course we can. There's a keyword called doPush. After you type that in, what devchan do we want to push? dvtp, system off button. And that's it. Once you compile and load your code, this timeline event will trigger every second, and if the current time equals exactly 10 p.m., the doPush statement will execute. Now that you know how to implement a timeline, let's move on to the exercise. As always, save your source code and close out of all your editor windows to prepare for the exercise.